Hey everybody, this is Dr. Green. Welcome to CS 6500 Big Data Analytics. This is the introductory lecture where we'll go over some basic and fundamental concepts in big data. Don't worry if you're taking this class as either MSA 6500, 6550, or as Data 6500. You are in the same place and this is the same class. So in this class, we will be talking about big data and how do we perform analytics on that data. So in order to talk about that, we need to start with a discussion about what big data is. First off, big data comes from a lot of places. Big data can come from transactions, things you're doing every day, from social media feeds, general activities you do everywhere on MacBooks, on laptops, on computers, on phones are logged, and we may need to dig through that. There's lots of public data out there about tons of different things that we may want to go through, old archive data, or even enterprise sources. I used to work with a colleague who had hundreds of thousands of samples coming in every second related to watching television in different ways, from multiple clients. So the data comes in all different formats from all different sources. And this is where we get our big data. That data in itself may have different types of structure. It could be well structured, well defined, have really standard relationships and well defined fields and records, and we know everything that's in it. We may also have unstructured data. This tends to be data that is not as well structured. Every record that comes in varies and has some differing information and even differing structure of the data. Commonly, you also have hybrid data that is mixed, right? We have structured and unstructured data that is mixed together. And we're often mixing and matching data. So you're going to see structured, unstructured, and hybrid data all throughout this. When we talk about big data, we also tend to talk about the V's. Originally, there were only three V's: volume, variety, and velocity, right? How much data, what type of data, and how different was it all, and how fast did it come in? Over time, folks have proposed other V's. I like this 8V methodology, right? Because it really shows the business case as well. We need to look for value in our data. We need veracity. We need to know if the data is true and accurate. We need to be able to visualize our data. We need to know how viscous or does the data stick with records or individuals. And we need to know if it has the potential to go viral and do things like this. So I think this is a really important thing to remember, and it gives us a great context for talking about data and its aspects. Regardless of the data or the V's or the source or the structure, the job of someone doing analytics is to take information and make it useful and actionable. So we start with data, we put it through our processes, and we end up with useful, actionable information. Okay? So this is where we're going. Now you may be asking yourself the question, isn't this data science? I really would like to point out that data science and data analytics are different things. Data science tends to live much more in the future, saying based on the past what will happen and what should we do. And they have their own set of tools and everything. Data analytics tends to live in the world where we have data coming in and it's either old data that's already been stored or it's data in the present. And we are asking questions around what happened or why did it happen. Okay, we're trying to extract useful, actionable information from that data. And you end up using tools like a Hive and Pig and Tez and Impala and Spark. Right? So these are some of the things we're going to talk about later in this class as well. In this process we use, right, using these tools has it changed over time. Originally, everything was a schema on write methodology, right? So we had raw data and very commonly ETL, right? Extract, transform, and load processes were applied, giving us a nice clean data set that was stored in a data warehouse or now a data lake. That data was set up so that people could consume it, right, and do whatever they needed to do with it. As we moved into big data and big data analytics, we replaced that, that ETL process with the use of our tools like Hadoop and MapReduce and Spark, so that we could transform the data, we could load the data, we could move the data around in real time directly from the source and not have to worry about these predefined data sets, which saves us some time and improves the process. Now you may be thinking this sounds like a very straightforward, easy process. Let me show you a slide from 2019. It shows the whole data and AI landscape. You'll see there are a crazy amount of products in here. They go from infrastructure to application to data sources. Some are open source, some have to do with analytics. There's just so many different things and they're related to different vendors. So much going on. It's very difficult for one person to be an expert in all of these, so we tend to focus on one aspect or live in our own area of specialty, even though we are aware of the other things going on. You'll see down in the bottom left, we have some things under open source about frameworks and query data flow, data access and databases, orchestration management, these places down here. This is where we are going to live this semester as we dive into big data analytics. Most of the tools used in this class will be these open source tools based on the Apache Hadoop stack, as I would call it. They start with data collection with products like Flume and Kafka and Scoop. Then they go into data storage with Hadoop HDFS, right? The Hadoop distributed file system. Things are moved around and managed by Yarn, yet another resource negotiator. MapReduce is a computing paradigm used to, split that data up and perform compute on it effectively. MapReduce in many instances has given way to Spark, which lets us do the same types of computations, but in memory, so we gain some speed. We access and query that data with products like Pig, Hive, and Mahout. We have data stored not just in HDFS, but also in HBase and Cassandra, these databases and NoSQL databases. And we orchestrate these services with something like Zookeeper. So we'll be taking a look at many of these throughout this course. So we're going to dive in pretty deeply there. The last thing I would like to talk about is that throughout all this, there is a process that's generally followed. In analytics, we start with a business question. Right, so almost everything we do in analytics is driven by a business question. There's a question asked. We have to identify what data will answer that question. We collect the appropriate data if need be. We process it or do this ETL, right? And then we do analytics. And that's where we're going to live. How do we extract useful, actionable information from this data that has been collected? And then you end up visualizing it, right? So to do some things so that people can understand the data in a very good way. One last thing about big data is that there are some very clear and concise requirements around big data as we use it. As I keep using the term, the data is big, it is large, so our everything has to scale. Our data storage has to scale, right? We have to be able to add more and more storage. Our computation has to scale because we need to work on more and more data. And our algorithms have to scale because we don't want to lose performance as we increase the size of the computation or data. This is going to be working in a distributed system, right? Most of these tools work within clusters of computation, meaning that we've connected multiple computers together in order to leverage the power and storage of all of them. So when you work in a distributed system, you have to worry a lot about reliability. Can I rely on the fact that my code will execute, that it will complete? What happens when a node fails or when something fails in the algorithm? So it has to be reliable. And because it's done on a cluster, we worry about utilization. Are we using all the resources we've allocated? We don't want to over allocate resources and just leave things idle, right? And we have some ways around that. That also makes us concerned about multi-tenancy. Typically these days, everything is run on virtual machines, and you have to ask these questions of which virtual machines can be together. Can they be close together? Can they not? Are there business cases where virtual machines I'm using for data from different companies cannot be together? Questions that we'll answer throughout the semester. We also worry about data locality, right? Where is the data? What data should be next to each other, and how do we store that appropriately to improve compute? I've also heard this stated as how do we bring the compute to the data instead of the data to the compute? So these are all requirements we'll be working through as we talk about many of these features. So in summary, we have Apache Hadoop. Hadoop gives us great distributed storage and resource management and computation. We'll be using that a ton throughout the semester. Spark is an extension of MapReduce that gives us in-memory performance for big data analytics. Data science focuses on the future, and data analytics focuses on answering business questions from the past. So this has been your introduction to big data analytics. I hope this is well, and I'll see you next time online.